everyone, and welcome to the Carolinas Explore event of the EnergyTech Up competition sponsored by the Office of Technology Transitions in the U.S. Department of Energy. We are very excited to have you all with us today to learn about new and exciting energy technologies that our students have selected and hear from our student teams about their business plans to facilitate commercialization of these technologies. Please note that we are recording this session and we'll be sharing it after the fact. So, to get us started, let's hear from DOE's Chief Commercialization Officer, Vanessa Chan. And then I see a blank screen.
Yes, it is hung up. It is frozen for me. Give me 1 second and I'll try to pull it up on YouTube.
You know what, Emmett, if we do that, let's move forward on the slides and we'll do that separately. We can do it before we launch into the pitches, if that's okay.
Sure, that works for me.
I do apologize. Okay. So we will hear from Dr. Chan soon. All right. So, okay. So if you were excited about coming today but don't know about the EnergyTech Up Prize, this is its inaugural year, and it really is unique in the context of competitions like this, in that it is really about business plans and not about startups. So it's really about what are the ideas and the creativity about commercialization, not necessarily about the backgrounds of the folks on the team. So that's exciting. Here at our Explore event, we will be identifying a regional winner and runner-up. Our regional winner will win a $2,500 cash prize. We will also be designating up to 6 technology bonus categories that I'll speak about in a moment. And those will go forward as semifinalists to be reviewed by various offices within the DOE. And all of those winners, the finalists from those categories, as well as the regional winners, will have the opportunity to present at the National Pitch Competition on March 24th. So we're very excited about this. The cash prizes are quite impressive, and we're excited to put our best candidates forward here from the Carolinas region. So on the next slide, we talk about these technology bonus prizes. So this is something that happened along the way where now we are able to name semifinalists in up to 6 categories that will be reviewed by their respective offices for the chance at a $2,000 finalist award, as well as advancement to that national competition. So they will be eligible not only for those categories at the national competition, but for those full overall prizes as well. So we're very excited to be able to put forward hopefully more than one team onto the national competition. So just to give you a little orientation to who we are as a Research Triangle Clean Tech Cluster, my name is Deb Wojcik, and in all of the tech issues at the beginning, I forgot to introduce myself. I'm the Executive Director of Research Triangle Clean Tech Cluster, or RTCC, and we were so excited about being the Carolinas Regional Convener because this aligns perfectly with our vision and mission, really to bring together industry and academia, as well as government, to advance clean tech, and clean energy is a big part of that. So going on to the next slide, we have 3 strategic areas, and this competition really touches on those in meaningful ways, particularly with innovation, really wanting to help facilitate, accelerate, and amplify innovation for clean tech and clean energy in our region, as well as education and talent development. And there isn't a much better way to do that than to be able to showcase these students having these amazing ideas today. Just to see how those overlap with our key focus areas: clean energy systems, smart utility technologies, and clean transportation. Clearly, those top focus areas are directly aligned with this competition and what we're going to see today. So we are so pleased and we are grateful to the Office of Technology Transitions for giving us this opportunity. So with that, I wanted to do a quick overview. So we have 10 teams who will be pitching for us today. Each team has 5 minutes to pitch. They have been with us for a tech review and know that they will get a warning signal at 30 seconds and then a closure signal at the 5-minute mark. And then you will have up to 4 minutes for Q&A for each team. So that will start with the judges. The judges are welcome to come off of mute. They will be on camera and listening throughout the competition, and they will be able to come off of mute to ask the first questions. You as audience members are also welcome to use the Q&A function on your Zoom screen to enter and type your questions. So if there is time for any one of the teams, we will go to those questions. We'll then have a minute for transition. Now, if we don't use that whole time, we have a couple of surprises up our sleeves. So we are going to stick to those 10 minutes to the extent possible. Keep in mind that this is really meant to be a supportive and exciting atmosphere, but not one for critique in the Q&A. This is meant to be for clarification and deeper delving, not for critique in that format. If you would like to see the full schedule of the 10 team pitches, we'll post a link where you can view that in chat. And you can also use the chat function if you have any technical issues or any other things where you want to reach out to us. After our 10 team pitches, and the next slide, please, we will have a break actually in the middle of those pitches, and then we will move into, are you seeing the slides advance? I am not. There it is. We will have a, great, thank you. We will have a 10-minute stretch break at the pitch halfway point. Please make sure you're back in time. We'll have a timer set to remind you, but we can't really pull you back to your computer screen. So we do hope that you can come back on time. And following the pitches, we have a featured guest speaker, Jason Massey, who is co-founder and CEO of Industrial. We will ask the student participants to complete a brief survey, and that will be the point at which our audience can choose their audience choice award winners. And then after the judges deliberate, we will come back for the announcement of winners. Okay, so with that, we are so grateful that you are all here, and we wanted to take a moment to allow each of our judges to introduce themselves. So Damien, you want to get us started?
Yeah, thanks, Deb. So Damien Beauchamp, President and Chief Development Officer here at 8 Rivers. We're a net zero solutions organization located in the ATC campus in Durham, North Carolina. Prior to joining 8 Rivers a little over 6 years ago, I was pursuing my PhD in chemistry at Ohio State University. While there, I started 2 companies, 2 startups. One was around stationary energy storage, and I actually won the DOE Clean Energy Business Plan competition at Rice University. So I have direct experience with what you all are doing today. I won it from Jennifer Garson at the time, who was running kind of tech commercialization. Won the Ohio State Business Plan competition, won the Ivy Business Plan competition. The DOE prize was for $100,000. In total, a little over $250,000 was won in about 6 months of the pitches that I gave for the stationary energy storage technology. That resulted in my being featured in Fortune and Forbes magazines. Well, at the Fortune conference that I was invited to speak at, I met the co-founder, Bill Brown, who I'm actually filling in for because he had a conflict. And so I think I'm a suitable fill-in. And then I had a separate startup that I did in parallel that I sold while I was in graduate school. So in addition to serving as President and Chief Development Officer here at 8 Rivers, I also serve on the board of TROSA, which is a local organization, nonprofit for helping recovering addicts and alcoholics get back into society. I also serve on the board of Net Power, which is co-owned by other Fortune 100 and 500 companies, Exelon Generation, now Constellation, Occidental Petroleum, McDermott. And yesterday we announced Baker Hughes has just invested in Net Power, which is also co-owned by 8 Rivers. And I serve as our board member in that company. So pleasure to join all of you. And this is exactly how my career started.
Thank you so much, Damian. Very, very relevant history, and certainly not a stand-in for anyone. Thank you for being part of this. Molly O'Donovan-Dix, would you like to introduce yourself, please?
Absolutely. At this time of day, I turn into a ray of sunshine. I cannot manage this sun coming across my camera, so I'll just try to lean forward. Yes, I am the Senior Director of RTI Innovation Advisors. And for those of you that don't know RTI, it was formerly Research Triangle Institute. And thinking about innovation, we are very proud of our history that RTI was started as a cornerstone for innovation, and it shows the link to economic development with what's happened in the Research Triangle area. RTI has last year just over $1 billion in revenue. We have over 1,000 clients and almost 6,000 staff globally. So our team is the Innovation Advisors. We've been in practice for over 50 years, and we sit at the intersection of business and technology, which is why I'm here to help today. So effectively for companies, government agencies globally, and universities, we help either work on kind of a tech push model where somebody's got a portfolio of R&D and they're trying to figure out how to gain value, find partners, and take it to market. Or on the reverse, more of a tech pull, we help support on the front end for forecasting and futures and idea generation, all the way through opportunity insight to partnering and other kind of tech scouting and landscaping. So this is what we do, and we're really excited. I'm happy to be here and help bring some of my insight to all of your exciting things you're doing.
Thank you so much, Molly. And our third judge today is Sal Gill. Can you please introduce yourself as well?
Yes, hey everybody, this is Sal here. Thank you for the opportunity to participate in this very exciting event. My name is Sal again, and I work for SAS Institute. We are the largest privately owned software company in the world, about $3 billion in revenues. And I head digital strategy and market innovation for the energy and utilities division at SAS. It's a very exciting role. We get to focus on what's new, what's happening, but more importantly, as you'll see in my quote below the title, we're always very curious to hear what the problems are in the industry that need to be solved. Because if a problem is not being solved for a customer, for an organization, then any idea that we may have remains an idea in this world. As for my background, I am an electrical engineer, and more importantly, for the Duke people in the house, I am a Duke alum. I promise I will be as unbiased as possible. But I am a Fuqua from the business school graduate from Duke. And my background, again, I've been in the industry 15 plus years. And prior to SAS, I was with ABB and other large vendors in this space. I've always been on the vendor side in our industry, focusing on everything that's happening in our industry, from electric vehicle, from electric vehicle introductions to battery energy storage deployments, having worked on some of the largest ones around the world in that arena alone, to now looking at emerging problems that are coming onto the electricity networks related to the deployment of renewables. So it's a very exciting time. I'm so pleased to see so much interest in this space from students. That gives me a lot of hope for our industry and for also enabling a decarbonized world as we move into the future, especially in light of the recent United Nations SDG goals that have come out. So looking forward to this. Deb and Emmett and I'll pass it back to you.
Thank you. Thanks to all three of you. This event would not be possible without the participation of our esteemed judges, and we are so honored to have three true experts in our field and in our region, and we are so fortunate to have your expertise with us today. So in addition to the official judging process that will determine who represents our region and moving forward, we will be asking you as audience members to select a winner as well. To participate, we ask you pay particular attention to these criteria. We'll post them again when it's time to vote, and that will be after our guest speaker, after the pitches. So keep that in mind. And we ask that you only vote if you have viewed at least half and preferably all of the pitches. So this will be a little bit of a different scale of awards, certainly bragging rights, and this will have some gift certificates for the team as well, for the winning team. Okay, so it is now time to turn the podium over to our first team, and we will get started with our pitches. As you may be aware, if you are checking the time, our tech delays at the beginning and going a little bit longer than anticipated has our time a little bit shifted back. But what we're going to do is we stick to our 10 minutes. We will move forward. If we do end up having shorter Q&As for some reason, we might catch up a little bit of that time, but we're just moving from here forward. So with that, our first team is our solar hydrogen from in-place methanol reforming, team 1. And Nicole Patterson, I see you here on your camera, and I will mute, and the floor is yours.
Awesome, thank you. And I believe David's going to share screen. Perfect.
Sorry.
Yep, I can see it, David.
Great. All right. Good afternoon, everyone. My name is Vincent. Today I'm with Nicole, David, and Ben to present SHIMMER, which stands for Solar Hydrogen from In-Place Methanol Reforming. To start off with, hydrogen isn't as clean as you think it is. The current standard of hydrogen production is steam methane reforming, or SMR. It is so emissions intensive that even when carbon capture is used with it to produce quote unquote blue hydrogen, there's 20% more greenhouse gas emitted than if you simply burn natural gas or coal for heat. And with most of SMR hydrogen production being centralized, about 50% of hydrogen cost is estimated to be due to last mile distribution. So SHIMMER, which is based on technology developed at Duke University, offers an innovative approach to address the shortcomings of the status quo. We employ rooftop non-concentrating solar collectors and renewable biomethanol feedstock to generate about 1,000 watts worth of hydrogen per square meter. At 43% solar efficiency, SHIMMER captures double the solar energy of current photovoltaic systems. And on top of that, SHIMMER features a desirable footprint because it's a rooftop system. So why is SHIMMER so unique? We see it disrupting the trade-off between low emissions and affordability. SHIMMER has lower emissions than blue or fossil hydrogen. At the same time, it's more economically feasible than electrolysis. SHIMMER is much greener than the current standard. As you can see in this chart, even in the worst case scenario, it meets the EU green hydrogen standard, in stark contrast to SMR. SHIMMER is also superior to the current standard of centralized hydrogen production because the methanol feedstock that we use for on-site production is cheaper to transport than hydrogen. This means that SHIMMER is cost competitive with blue hydrogen when its point of use is 200 kilometers away from its source of production. As you can see from the map, 200 kilometers is about the distance from Charlotte to Raleigh. And also we're cost competitive with green hydrogen everywhere. With all of these benefits in mind, we've identified a very promising beachhead market in the form of high volume warehouses. We project a serviceable, obtainable market of around $30 million by 2027. And this is largely driven by the growth of hydrogen use in forklifts. The DOE estimates that actually 65% of forklifts will use hydrogen by 2050. So we initially want to focus on forklifts because it's the most immediately accessible and attractive market. But within the same beachhead market of high volume warehouses, we also see the potential for SHIMMER to be eventually headed for truck fleets. So now I hand it over to my teammate David to discuss the specific needs of our beachhead market.
Thank you, Vincent. Major distribution network operators already recognize the business value of hydrogen-powered forklifts and are investing in their future. Hydrogen forklifts are operationally superior to battery forklifts because of reduced charging time and more consistent power over the course of a shift. An on-site solution serves this need with a lower environmental impact and cost than a centralized solution. And Shimmer outperforms our competitors for on-site hydrogen production in cost, environmental benefit, and desirable footprint, driven by its unique use of free solar heat and its rooftop installation. So how will we seize this opportunity? Shimmer will sell modular systems to match the scale of our customers. 10 modules will supply the needs of a large distribution center over the system's 20-year lifetime. This presents a compelling opportunity for distributors to meet their sustainability goals and improve their operations while generating an internal rate of return of 11% with an easy transition and attractive space footprint. How do we get there? Shimmer will scale catalyst production to kilograms and develop our robust solar collectors by 2024. Over the following 2 years, we will move from pilot customer programs to a large installed base as major customers deploy Shimmer to serve their hydrogen fleets. By 2027, we're targeting 40 warehouses and $6 million in operating profit. Now, what does this mean for the world? Equipping one distribution center with Shimmer is equivalent to taking 300 cars off the road for 20 years. Shimmer aids the energy transition to clean fuels. If a customer wants to deploy a hydrogen road vehicle fleet, they simply install more Shimmer modules. And Shimmer, even for forklifts, builds on growing momentum in methanol and hydrogen and combines the power of those trends. Finally, by reducing electric demand and the concentration of pollution around power plants, Shimmer benefits historically marginalized communities by improving air quality. The American Lung Association has estimated that pollution specifically from power plants is responsible for approximately 13,000 excess deaths annually in the United States. Solar hydrogen from in-place methanol reforming offers a cost-effective and environmentally friendly solution to enable a distributed green hydrogen economy. Thank you, and we welcome your questions.
Yeah, this is Damien.
Thank
First
you so much.
question. Oh, sorry. Sorry. Are we allowed to ask questions or?
No,
Yes.
perfect. I was just making sure that you all were coming on to do that.
Yeah, what's your, so first question, what's your levelized cost of hydrogen production on a per kilogram basis? Second question, in that levelized cost of hydrogen production, do you account for the cost of compression?
$3.70 and no.
And what is the capacity factor that you're assuming for a hydrogen production?
We're assuming hours of sunlight based on Salt Lake City, Utah, which is 3,029 hours per year.
Molly, or Damien, do you have any more?
Please. Yeah, I might have a question or two more. But move on to the other ones. Please.
Yeah, I can go next. Thanks, guys, for the presentation. Couple of quick questions. I see that you've looked at some alternatives, but have you considered what substitutes there are in the market as well? Not just immediate alternatives, but what are the substitutes? If you look at just a warehouse space, Amazon is using a whole bunch of different technology to move around items in their warehouses. So I was curious if there's been any research done into alternatives from a substitute mindset.
Yeah, for sure. I mean, the broadest job to be done here is moving goods around in a distribution center or warehouse. And certainly with increased automation, even beyond automated forklifts to package handling systems, there may be fewer forklifts at large customers in the future. Even with that trend, our system will be attractive to a very broad market, and we anticipate strong demand from less automated producers, as well as very automated producers as they scale overall and still require quite a few forklifts, and beyond forklifts, fuel cell solutions and future markets in a point-to-point trucking distribution network between their facilities.
So if I understood correctly, your solution is based off of utilizing solar to a large extent. Is that correct?
Yes.
So are we going to be restricting the market size to places where there's high solar irradiance patterns, versus a country like the United Kingdom as an example, where, the sun may not always be shining. So what's your thoughts on that?
This is attractive as an investment from the customer perspective in most of the United States, especially around strategic fuel corridors, such as between Chicago and Salt Lake. The United Kingdom probably doesn't get enough sun. Your internal rate of return would be in the low single digits in a place like that. But if you wanted Shimmer, you could build a larger system with a higher capital cost. So it would work. Some of the economics, especially for the beachhead market, are driven by the hours of sunlight per year. So Salt Lake is what we targeted because we see that as an area with less hydrogen distribution and a very strategic transportation corridor in the United States for our cost targets. The internal rate of return is much higher, for example, in Tucson, where you have 3,800 hours of sunlight per year instead of 3,000, and that pushes you up a number of percentage points. So whether this is attractive depends on each company's targeted IRR and sustainability goals.
And last question, and that's more around sort of tailing off from Damien's point. This is regarding efficiency.
Yep.
Hydrogen is still, it's getting there, but it's, from a efficiency perspective, it's still not there compared to, where, for instance, batteries are. So any thoughts on that?
Yeah, so there are other companies that provide fuel cell solutions for forklifts that are seeing strong market adoption. The two key things are that even if it is a little less efficient, if you were putting electricity in it, because we're putting sunlight into it, you get over some of that cost. And second of all, you have those operational advantages with no space needed for a battery room, minimal charging time as you just refuel, and the batteries don't drop voltage, which you can manage, but they don't drop voltage over the course of a shift. The fuel cell is the way a battery would.
Thank you.
Thank you. We're almost out of time, but Molly's had her hand up for a while. Let's give her a chance to ask her question, please.
Sure. I was just interested in why it's going to take 5 years to get to 40 warehouses when that's not a huge number.
Because the technology is in lab scale right now. And so the first few years are to develop the scaled solution and prove it out and begin pilot programs in 2026 with large customers before they.
Yeah, not much of the technology is novel. It's more so just scaling. So like our catalyst example is not particularly novel. The collector is not particularly novel. It's just integration and scaling, which we think is doable in the 5-year timeline that we laid out.
Great, thank you.
Thank you all. We appreciate that, Team 1. And if we can have Team 2, please come on screen and get ready to share your slides and share your pitch.
Thank you.
Our next team is GeoExplore, and our timer will be, looks like it's going to be able to be functional this time. So just let's get started with our 5 minutes. We are going to need to be a little more attentive to our 4 minutes of Q&A time. So let's make sure we can get concise and tight answers, as well as let our judges all have a chance to ask those questions so we can dig in. Thank you.
Sounds good. Well, we're GeoExplore. We're all students from Duke. We worked alongside Dr. Beckers from the National Renewable Energy Lab, who developed the software we're presenting on today and also advised us along the way. Today, we'll be going over the geothermal market, the tech itself, the business details, and lastly, the potential impact. So starting with sort of the why, we decided to focus on geothermal for sort of 3 main reasons. First, it's because it can power millions of homes 24/7, which can make up for the intermittency of other renewables. Secondly, it plays to big oil strengths, such as drilling, which can accelerate the green tech revolution that's going on in that sector. And lastly, it's just recent tech progression in the field, such as enhanced and closed loop systems, which are essentially technologies that allow geothermal to happen anywhere.
We focus on GeoFires, a geothermal techno-economic simulation tool, and the Slender Body Theory Simulator, or the SBT. GeoFires uses reservoir data to estimate the lifetime energy production and the overall cost of energy for any geothermal plant. SBT, on the other hand, simulates heat transfer with slender bodies in a medium and can be integrated with GeoFires. It is the first software to specifically simulate closed-loop geothermal systems, predicting the profitability of a closed-loop system within seconds. And they can work together. The GeoFire simulator can have as input the output for a separate reservoir simulator like the SBT. They will both be open source and they can exist on the same website where the user can download them to perform an overall technical and economic simulation.
Our technology will address two major pain points. First, GeoExplore addresses uncertainty in the exploration phase by improving location selection and thus increasing the profitability of geothermal plants. Second, GeoExplore reduces computation speeds for closed loop systems to a matter of seconds. Next slide. So this is the financial breakdowns of our pain points. So there are high upfront costs to geothermal plants that make up 42.3% of all development costs. But models such as ours will boost exploration success to 40%, which is similar to that of oil and gas, and make wells 20% more productive. And this is estimated to have a financial impact of $10.4 million per plan. Next slide.
And so ultimately, we believe our software can be used by a few key players. First, by academia to push the theoretical forward and optimize closed loop systems. It can be used by government to simulate district heating systems. And it can be used by private industry, anything from geothermal startups to big oil, to find ultimately the most profitable geothermal reservoirs. There's a few key competitors in this space. So first is in-house software, which is sort of software built by the companies themselves. But we found that this market is highly confidential, which sort of slows down the diffusion of information. Secondly is external software, but we found that this market has no dominant player and is extremely fragmented and isn't rigorously peer reviewed. And lastly, on the global stage, there are a few softwares similar to GeoExplore, but we believe the next frontier for competition is going to be closed loop systems, of which GeoExplore is the first software which can execute these simulations. Ultimately, we hope that GeoExplore can consolidate this fragmented market and ultimately solve this disconnect between the academic world and the privatized markets.
Okay, so now let's talk a little bit about profitability. These are the revenue and cost breakdowns that we achieved using data from Dr. Becker's. And we found that we need to sell 66 licenses in order to break even and recoup the upfront costs, and that we would have $10,000 in annual net profit without accounting for licensing. Next slide.
So our team plans to use an open source business model because we believe it best fosters an accessible and also collaborative work environment for the academic community and industry. We also want to carry a triple bottom line, which means that in addition to social and environmental concerns, we intend to make profits through services such as customer service and also premium software access. And we also want to use public forums, conferences, and grants to increase our product's visibility. Next slide, please. So the potential impact of geothermal energy is boundless. For instance, there are many notable similarities between geothermal systems and then also today's oil and gas industry, which may ultimately help to ease away from non-renewables. Recent projects such as the Eno Green Power Hybrid Plant in Nevada also suggest the promise of geothermal hybrid systems in providing more reliable, resilient, and stable energy for all. The most exciting about all of this is that the marrying of SBT and geofires has been very successful thus far. We're excited by our software's potential to actualize $10.4 million in financial impact per plant and to democratize geothermal for all, and we're now happy to take any questions. Thank you.
Thank you, team. I think we'll start, let's see, I can't actually see the judges, but judges, you are welcome to come off mute, and we will stick to our 4 minutes if we can. Thank you.
So I'll jump in and go first. It's the nature of this format. I know it's really hard. You guys go very fast. Can you go back and just talk a little bit about that profitability and the $10,000 again? I just wasn't able to catch that.
Yeah, for sure. Once we get to that slide, I can break it down. So the 10K in annual net profit is when we're just only accounting for the advisory services and potential grants, and then the service costs, service labor per year and maintenance per year. So that doesn't include any licensing because we can't really estimate how many licenses we're going to sell in the first year because the private softwares that a lot of private companies use for currently isn't really well known. So we didn't want to place an estimate there. So we broke it down from licensing to without licensing.
And how did you set your licensing fee?
We consulted with Dr. Beckers on where to price it and where he felt most appropriate, because this is his software that he owns. And he was very adamant on having it be an open source model, which is why we opted for licensing and advisory services as our potential revenue streams.
Great, thank you.
I can go next. What are some of the variables that your software is sort of trying to identify? Is it the, is it the location itself, obviously, but is there, what else is there that you guys are trying to identify? And do you guys use any, or is there a need for any external data sources to be integrated with your tool?
Yeah, there's a few like key data points that it looks at. It can take up to like probably like close to 50 to 60 inputs. But a lot of it is based on assumptions of like historical averages, like upfront costs and stuff. But some key metrics is sort of like well depth, along with like the temperature at like different elevations of the sort of like region that you're drilling at. And so that's a key determinant of how much energy you can get out of the well. And so there's a lot of sort of like a little bit of like legwork before the exploration where you have to collect that data geographically, but that makes up a small part of the sort of like exploration costs. And we're hoping that this software can sort of reduce a lot of the other costs that happen to do with like more in-depth exploration. So yeah, some key data points like well depth, temperature, and also like permeability of the region are like sort of the main inputs you put in.
Yeah, and just to add on to that, drilling is usually the most cost intensive. So by having our model estimate where are the best locations to drill, companies don't have to drill in as many places to do exploratory drilling and things like that.
Great. Are there any other questions? Okay. Well, thank you so very much, team. We appreciate it. And we will bring team number 3 up. I wanted to note, and I will also post in the chat, that in order to try to regain a little bit of time, we will be shortening our break to 5 minutes after team 5, but we're still a couple of pitches away from that. All right, team 3, we will be hearing about solid state battery for EV and battery storage.
Can everyone see the screen?
Yes, you're good to go.
All right. Hi, everyone. Thank you all for coming. Today, we're going to be presenting on solid-state batteries with ceramic separators in electric vehicles and grid storage.
Thank you, Alex. So I'm going to first start by talking a little bit on the introduction of what is solid-state battery. As we can see on the left of the screen, it shows a conventional lithium-ion battery, which pretty much consists of 4 parts, a cathode, an anode, a separator in between, as well as an electrolyte that runs the lithium-ion through. The difference in solid-state battery is that the traditional anode that consists of carbon or carbon silicon mixture is replaced with a pure metallic lithium. And with that removal comes a lot of benefits. First, in energy density, as the removal of carbon removes the volume and the and the weight comes with the carbon, as well as a variety of other benefits, including fast charge, longer cycle life, better safety, as well as cost reduction. Slide, please. When looking at the general market for solid-state battery, we believe that it coincides with the battery for lithium-ion, which has good future prospects in terms of growth. It's estimated to grow at the rate of 19% in the next decade, mainly driven by industry tailwind from the electric vehicle industry, as well as large-scale industrial grid storage. Slide, please. When looking at sort of the local market for solid-state battery, we see that the different batteries really differentiate itself through the different separator used. From polymer sulfide to the ceramic technology we're pitching. The ceramic separator really enables the overcome of major technical hurdles among industry peers, leading to good conductivity, chemical stability, as well as resistance of dendrite formation.
Now I'm going to talk about solid-state batteries economics in terms of price. So for solid-state battery to be able to compete with lithium-ion battery, it will need to reach a similar price level as lithium-ion. And this is indeed possible. Multiple companies such as Nissan estimate that by 2028, solid-state batteries price can reach $65 per kilowatt hour, despite the current high price of around $500 to $800 per kilowatt hour. And lithium-ion battery is projected to reach a similar price level by 2030 as well. And given the advantages of solid-state battery, a lot of driving range, safety, and other benefits, it will be able to compete effectively with lithium-ion battery. And although this price reduction is quite significant, it's feasible, since lithium-ion battery's own price declined by over 10 times from 2010 to 2020. Next slide, please. So in terms of cost, solid-state battery has the potential to achieve a higher profit margin than conventional lithium-ion battery, given its elimination of anode material, which simplifies processing and reduces material costs. And on the left, we show a cost breakdown of solid-state battery in a scenario of $140 per kilowatt hour. Next slide, please.
Next, going into the potential impacts of the solid-state batteries. First, I'll discuss its role in the energy transition. Solid-state batteries can improve and advance two main products to fuel the energy transition, and the first is battery storage. Many renewable sources today, like wind and solar, lack on-demand reliability. So more effective battery storage system will make renewable energy sources ready to overtake fossil fuels. Traditional lithium-ion batteries are currently mainly used in battery storage technologies, and solid-state batteries can improve it by increasing the energy density, efficiency, and safety, as mentioned before. The second product will be electric vehicles. So electric vehicle developments currently are blocked by the hurdles of high price and low mileage. By switching to solid-state batteries, higher energy density will solve the mileage issue. And like mentioned before, solid-state batteries can reach competitive price in the near future. When solid-state batteries are applied to electric vehicles, again, they are more ready to tackle the largest emitting industry currently. Next, talking about some of its other social impacts. First, it will loosen the current strain on the cobalt caused by the dependency of lithium-ion batteries, which has cobalt mining has led to a lot of environmental and sustainability issues. Second, decreasing battery price of clean energy can increase access for middle and lower income. Also, switching from traditional lithium batteries to solid-state batteries will not create any significant changes for energy infrastructure. And lastly, and also the other application of the solid-state batteries can lead to more jobs and that can compensate those in the fossil fuel industries.
Finally, our business plan. So in the initial stage, our goal is to show feasibility of solid-state batteries applications, vehicles, and other uses, such as grid storage, by seeking investments from VC firms and partnerships with leading downstream consumers, such as vehicle manufacturers. Next slide, please. In next stage, we'll scale up production before 2030 based on results from the initial stage by introducing products through partnerships, continue research and development, and market products by focusing on competitive advantages, and finally, enter market regions with relatively low penetration alternative technologies. Thank you.
Yes, so I think that was a good job, guys. So Damien Beauchamp here. Actually, what I competed with in all my business plan competitions was a potassium oxygen battery. So very familiar with battery technology. What I would say is probably on the EV applications to be aware that specific energy is more the driver of increased range than energy density. So that's a factoring, weight as opposed to volume. But with respect to dendrite growth, I mean, what are you guys seeing as kind of the main failure point for these batteries? And then what is the current cycle life for kind of state-of-the-art solid state lithium-based batteries?
Yeah, I think I can first touch on a little bit on the dendrite growth part. We can see that we previously mentioned that the difference in solid-state battery is the separator used, and a lot of the other separator except ceramic includes sulfide as well as other polymers. And in the testing phase of sulfide and polymers, there is an exhibition of sort of the problem of dendrite growth within, and ceramic sort of relieve that problems on a single cell basis. However, I think we think the challenge in the future is that for ceramic separator, all the test data comes from a single cell sheet, and we'll see sort of when it's scaled up to the size of actual like an electric vehicle battery size, it can still keep up with the performance data. In terms of the cycle life, we don't have a specific data at our hand right now, but that's something that we can definitely look into.
With respect to so is the innovation here the separator material?
Yes.
I see. But your business model is to sell the battery.
I our business model is pretty much, I guess, the different phases that the battery has to go through through different time points to make sure it is, up to speed to compete with the current players in lithium-ion battery.
Do we have other questions? We've got about 2 more minutes for questions.
So someone from the team, just to bounce off from that point, if you were to describe in one sentence what problem you're trying to solve with this, new innovation, how would you describe it?
Yeah, I think the main problem we're trying to tackle here is to improve rechargeable battery storage performance through the increase of energy density, as well as other battery performance matrix.
And I think following up on that, increasing the battery efficiency also can open up to a range of different battery applications, especially in the electric vehicle, also new battery application, for example, in drone delivery and also last mileage, kind of a hybrid or just purely electric fuel kind of ferry boats as well. So just having this kind of increased energy efficiency and safety can open up to a wide range of possibilities that we don't know yet.
Molly, if you're okay, if I just ask one more question, because with batteries, this always comes up. It's actually a two-part question, but one is the lifespan. I think that's, again, bouncing off of something that was discussed previously, but, average lifespan of the potential technology here, but also what is your guys' vision on recycling some of this stuff as well?
I think in terms of lifespan, we don't have a specific number, but test data do shows that because of the removal of carbon in the anode, sort of that comes with the removal of unwanted reaction between the electrolyte and the carbon. So there is an increase in lifespan compared to traditional lithium ion. And on the second part of the question, I think, sorry, Sal, can you remind me?
It was about recycling, but we can revisit it. We're going to be out of time here.
For sure. Thank you.
Thank you. Well, thank you, Team 3, for your pitch and answers. And I see Team 4 coming on screen. They will be speaking about affordable and clean iron-air grid technology.
Yes, I'll be sharing my screen in just a second. All right, Matthew, whenever you're ready.
All right. We are Brandon, Ben, Matthew, and Manu from Duke University and the University of Utah. We're presenting on iron-air batteries. So one of the major hurdles currently facing many alternative energy industries is the fact that energy sources with inconsistent outputs make the grid less efficient. Solar power generation peaks at noon on a good day and tapers off to nothing by sunset, right as energy demand is ramping up. Traditional power plants are needed to supplement the ups and downs of solar energy. Unfortunately, these plants operate most efficiently when run continuously. In order to efficiently supply evening power, we must run these plants throughout the day, leaving us with an energy surplus at peak solar periods. Storing surplus solar energy is the key to solving this issue. The problem with this is that we currently don't have the storage. It's estimated that to achieve 100% solar power, we need 3 weeks worth of storage. As of 2017, California had only 23 minutes of storage. This storage would come at an enormous fiscal and environmental cost. Our solution is to invest in low-cost iron-air batteries for grid storage. These operate using an iron anode and an atmospheric oxygen cathode.
So iron-air batteries have several advantages over their lithium-ion counterparts, especially for mass grid storage. Iron-air batteries are ideal because they have higher charge densities, which are 1,200 watt-hours per kilogram versus lithium-ion 600 watt-hours per kilogram, and higher energy densities, which are 9,700 watt-hours per liter versus lithium-ion's 2,000 watt-hours per liter. Iron-air batteries have begun to see charges lasting over 100 hours, and this combination of longer charge duration, higher charge densities, and higher energy densities makes iron-air ideal for the stationary nature of mass grid storage needs.
Moving on to the market analysis, we envisage our potential clients, the market essentially is utility scale production of solar and wind power in the US, which currently stands at 91 and 338 billion kilowatt respectively. However, battery storage for this market is only 1.6 million kilowatt hours in 2018. The key geographies that we potentially want to target will be California, Texas, Massachusetts, and Hawaii, with our clients being independent system operators, state and local governments, and regional transmission corporations, which is expected to be at around 10,000 megawatt hours in 2023.
Okay, so now I'm going to go on to talk about the cost of production for iron air battery technology. So currently, capital costs are estimated to be approximately $20 per kilowatt hour when part of a total system. And this price point is, in the short term, the cost level required for long duration energy storage to play a significant role in the decarbonization of energy systems. And this price point can also save grid users approximately $27 million per gigawatt of peak demand per year. The other benefit of this cost is that and the production is that it incentivizes substitution away from coal, fuel oil, and natural gas, which in effect would eliminate the need for natural gas or any other type of combustion power for fuel backup. And iron air technology can be placed in both rural and urban areas to meet utility scale energy needs and increase consumer demand for clean technology. So currently, a high density 3 megawatt system requires about 1 acre of land.
Now onto the business plan. We envisage an asset-light business plan wherein we undertake the production, maintenance, as well as servicing for these batteries, and the clients provide the land for it. Essentially, our partnerships will be public and private, focusing with state governments, ISOs, and regional transmission corporations, as I mentioned earlier. We also envisage partnerships with potential financing firms, particularly venture capital, as well as public funding. And in terms of the key resources and personnel, we envisage hiring personnel who are substituting away from the fossil fuel industry into the clean energy industry in the US. On to the metrics for success. So we want to measure our success on 3 different terms. The first is the substitution away from carbon intensive goods, which is basically the traditional fossil fuel industry, and the megawatt hours that's produced using our technologies. Increased rural economic development, so the amount of electricity that is supplied to rural regions within the United States. And finally, the partnerships that we're able to inculcate with ISOs and governments, and we envisage, we want to measure that over the period of the next 5 years.
That was a perfect finish. Thank you so much.
So I'm biased. So obviously I just mentioned I know air batteries well. What's the over potential required for these systems?
Sorry, can you repeat that one more time? The over potential?
Yes, the over potential.
So I'm imagining in terms of cost and also like the over potential for the technology.
For comparison, over potential is the potential for the volts required for charging.
Sorry, I believe that it's like I believe it's 1.2 volts. I would have to check that again. I'm sorry, I don't have it immediately on me.
Okay. And then what is what's the overall model of the business? Would it be to sell batteries, own and operate? Is it energy storage as a service using a low cost battery? Is it selling the batteries?
Yeah, the model is essentially to manufacture and sell the batteries, as well as provide their services and maintenance, whereas the other capital cost we envisage will be borne by the clients in terms of any capital investment in terms of land and others.
And do you know the solvent for the system between the anode and the cathode? What's the solvent system?
I'm not actually sure on that. The specific batteries we were looking at did not allow us to see that. It was proprietary information.
Got it. Understood. Thank you.
I can go next. You guys talked about, I think, real estate a little bit, about how much real estate this could take. I think I heard the figure of 1 acre, maybe. Correct me if I'm wrong. How does that compare with existing battery technologies? And is it a smaller footprint? Is it a larger footprint? If someone can comment on it.
Yeah, so as far as the pure size goes, it's approximately the same. It's mostly the cost that's going to be driven down, especially in comparison to lithium batteries. The other benefit is that, so for example, the technology doesn't have to be spread out thinly just on one floor. It can be built for multiple levels so that it doesn't have to occupy 3 floors over 3 acres, to be 3 floors for 1 acre. And again, as I mentioned, this can be useful for both rural and urban areas.
Are you guys aware of this Bill Gates backed company called ESS? I came across it, a couple months ago. They've been in the news, and this is a very, we see startups coming up all the time and sort of drifting away in the battery space, especially over the last 5-6 years. How do you stack up against, existing competitors?
Yeah, that's a great question. So Bill Gates had actually invested about $240 million in a similar company called Form Energy. So that would be our prime competitor. And I think our business model could stack up just as well, given that they haven't reached commercial scale. They're still in the development process, and they've shown proof of concept, but haven't officially moved into the business world yet. And I think that's where we have a good competitive advantage.
So I'd like to ask the market data you were using was from like 2018, and obviously a lot has changed in that window. Is there a reason? Was it hard to find the data? Do you feel like there's some reason that the data was from 2018?
Yeah, so the data for storage capacity at that point of time was for 2018, but as I mentioned that the renewable energy production is increasing, we didn't want to guesstimate the storage capacity at present because a lot has also changed over the pandemic, which is why we relied on that data. But our essential idea is that it has not increased by a lot because not a lot of new players have actually deployed the technology in the market as yet.
Okay, great. Thank you.
Thank you, Team 4. So we're going to move on to our Team 5, the last team before our short break. They'll be presenting on high volumetric energy batteries for wearables. We're on a battery streak. These were randomly ordered, and yet we are in a battery mode. So go ahead, Team 5, you can go ahead and share your screen and get.
Oh, hello, is my video on? Hello, my name is Dean, and this is my partner Chen, and we are working towards preparing a high volumetric energy density battery for wearable electronics because we see a growing demand for such devices in this market. A market analysis study was performed back in 2021 in October that showed the economic growth of wearable technologies is roughly about 13% per year. One of the reasons for this is because not only do we have smart watches, smartphones, but eventually we'll probably see smart shirts, smart shoes, smart belts, and smart hats in the future. And as these avenues for apparel grow, they're going to be powered by these energy storage devices. So we also have to improve on the science behind the battery in order to reduce like the charging time, because you don't want to go to bed every single night worrying about having to charge your watch, hat, belt, and shoes. So what is our approach in doing this? Well, your conventional composite electrodes are made up of multi-layering of different components. So the cathode and your anode are what provides your energy to your cell. But in there, you also have your inactive components such as your current collector, your separator, and your packaging and wiring. These inactive components reserve valuable space in the battery that do not provide additional energy. So what we want to do is grow a thicker cathode and anode to not only decrease the volume and mass that each battery has, but also save on material that goes into these batteries. So one of the challenges of this that we see is your conventional composite electrodes, the ones that you have in your phone and in electric vehicles, are all made up of active material, your polymer binder, and your conductive carbon. The polymer binder is there to add mechanical integrity to your electrode, and the conductive carbon is there to help conduct the electricity between the current collectors. So in thinner electrodes, the lithium transport does not get affected as much with the inactive components in it. But when you try to increase the cathode or anode thickness, then that limitation on transport does become significant. And that's what reduces your discharge or charge rate. So what we are planning to do is, by removing the conductive carbon and the polymer binder, we're able to not only add more active material to the batteries, but also promote the lithium ion transport to help this charge and discharge issue. So our current prototype is with the 2032 coin cell, which has a diameter of 2 centimeters and a thickness of 0.32 centimeters. And our achieved prototype is already providing 100 milliamps capacity, whereas commercially rechargeable 2032 coin cells are only providing about 40 to 70 milliamp capacity. So we're already improving upon commercial standards. And our current target is to achieve a single capacity of around 200 milliamps to be comparable to commercial single-use cells. The advantage of this is it's going to improve the customer experience because you have to do less interaction between the customer and replacing the cells. And current single-use batteries, you are not able to recharge those. And instead, with the prototype that we have, you're able to induce energy harvesting there. So say a smart shoe, as you're walking, your battery could be charging with the energy you put into each step, which cannot be used with the single-use ones. So your lifetime actually becomes more an issue with how long will your shoe last before you replace it instead of the battery itself. So the other advantage of this is that it's going to help improve the sustainability of your batteries. Instead of using single-use cells, if you're able to put in a rechargeable cell that does the same use, you're able to take away that many more components to it. And also, by reducing the amount of binder and conductive carbon in, it's going to help increase the recyclability of the batteries. Thank you. Any questions?
Molly, go ahead.
Do you have any insights in terms of your business model, in terms of your addressable market, your timelines, just anything more towards kind of the business model on the economic side?
Yeah, so we're currently still in the research stage. So currently we are only like doubling the capacity of the rechargeable ones. We're still approaching the primary use ones. Then once that stage is reached, we'll probably start considering building some relationships with like wearable devices, like for example, some glucose monitoring stuff, like the transmitters and some neurostimulator stuff like that. And perhaps if everything goes well, we'll probably go into some smartwatches or stuff like that.
Thank you.
What's the round trip efficiency and cycle life right now, current state?
So for cycle life, the current data we have, although it's not like fully loaded one, for the center electrode structure, we have 60% retention after 1,000 cycle and 80% retention after 200 cycle. So what was the other part you were asking?
The round trip efficiency.
Oh, you mean the voltage efficiency or? like that, or?
Yeah.
Yeah, so depending on
the round trip of efficiency as far as amp hours in and then amp hours out. Watt hours in, watt hours out, if you will.
It's pretty much close to, I guess, over 99%. Yeah. I mean, depending on the charge rate, because the thickness of our cell you're using for each electrode is over like 1 millimeter. It's really thick, so we can't really charge very fast. So at low rate, like 1 milliamps, it's pretty stable, I guess.
Does anyone have any additional questions for this team? Okay. Thank you so much, Dean and Chen. We appreciate everyone's pitch from the first half. We will take a brief break. As I mentioned earlier, we're going to reduce that to 5 minutes. It looks like, well, it's 4:13. We will come back at 4:20 to start, which means we will be 10 minutes off of the schedule. So let's do that. We'll come back at 4:20. Please make sure you are back. We will set the timer, and it is going now. We look forward to seeing you then. All right, if that doesn't bring you back and get you ready for the second half, I don't know what will. Thanks, everyone. Okay, as we rejoin, we are going to start on the second half of our pitches. Our next pitch will be the Solar Shepherds Incorporated Agrivoltaic Solutions, and I see them coming off of mute. Thanks, Lenny. And if you could get ready to screen share, we will get started.
Hi, so we're Solar Shepherds and we're here to talk about agrivoltaics. While the US energy grid needs to develop to become more sustainable and resilient, we also need to find ways to incorporate renewable energy into rural economies. All across America, small farmers and rural landowners are struggling to make enough money to keep. Climate change and degraded soil quality add to these agricultural challenges, often leaving selling generational land as an only option to afford payments. Here's our solution. Solar Shepherds specializes in agrivoltaics consulting and financing, designed to connect investors with small farmers and rural landowners. Landowners can generate a passive income through renewable energy development and active land management, producing solar energy while restoring soil quality with little initial investment. By providing financing for solar with a lifetime O&M agreement, landowners can profit from solar, retain their property and agricultural tax bracket while supporting the grid and energy infrastructure. Our company is altering historically exploitative solar financing models into a mutually beneficial system for both rural landowners and solar developers.
Our business model helps diversify the grid as well as the savings portfolio of small-scale agricultural producers. 50 acres of land can produce 5 megawatts of solar energy, and the US needs to install an average of 35 gigawatts of solar energy per year to aid in the transition to net zero by 2050. Bringing farmers into the energy transition allows for more equitable gain from solar energy production. It directly benefits rural landowners and communities while still securing returns on investment. Providing operations and maintenance services as part of the agrivoltaics contract ensures better system longevity and expanded options for cultivation. Our business starts with financing socially responsible investments and the option of a host of federal grants for these agrivoltaic installations. With these inputs, we then produce sustainable energy, agricultural products, renewable energy credits, and carbon offsets through soil restoration.
Our ideal customers are small-scale farm owners with at least 50 acres that are looking to get more use out of it. Whether this desire stems from struggling agricultural production or motivation for passive income, we will make their land more productive by improving the soil quality and more profitable by adding new revenue streams. Our job at Solar Shepherds Inc. is to make the agrivoltaics installations as simple as possible for all parties through a 50-acre modular approach. We interact with the farmers to ensure land suitability and allow them to select a desired level of engagement through growing crops that are shade tolerant or allowing for sheep grazing through contracts with local shepherds. We engage socially responsible investors and secure capital costs as well as return on investment. We negotiate energy pricing with the utilities to ensure solar energy profitability. And in addition to commissioning and managing the solar construction, we take charge of O&M and decommissioning at end of life. Looking at finances, we coordinate contracts with energy providers to sell power for anywhere from 5 cents to 12 cents per kilowatt, depending on the location. And then socially responsible investors or loans pay for the solar system and its construction with a 15 to 20-year repayment plan at 7% annual interest, which we've modeled and accounted for. Depending on local energy rates, approximately $2.5 million of remaining profits will be split between the farmers and our company. Farmers still receive all profits from their agricultural goods produced while we assist in the sustainable land management techniques. And at the end of the day, there's potential to sell carbon storage credits and renewable energy credits in some areas. Solar financing isn't new. Farm loans aren't new. We're just finding a way to give struggling landowners a retirement fund while maintaining generational land and livelihoods. For us, a successful mission looks like investors getting their money back with high enough returns to justify the investment, a more sustainable energy grid, improved long-term soil quality for the farmers, rural family farmers keeping their land when they otherwise wouldn't be able to, making that land more profitable through multiple functionalities, and adding resilience to the grid by decentralizing production. Bye.
Can we ask questions now? Or?
Yeah.
Okay, so I heard you say, financing isn't new, but I think at the core of your pitch, it is around financing, right? Or securing an investment strategy for these farmers. What is the difference then? What's different at the heart of this approach than what's in the market today?
Yeah, so basically the utility solar system right now is either land lease agreements or purchasing land from farm owners or rural landowners, and then installing just solar systems. Typically an O&M contract like that would be mowing it, so paying fossil fuel lawnmowers to come and landscape to keep the grasses down. And the land doesn't get used for anything other than just solar. And a lot of times these are huge corporations that come in and build hundreds of megawatts at a time and directly work with utilities for that. So it's not really providing anything other than maybe installation jobs for local people.
Yeah, you also have like communities that are like agricultural producers that really don't like these solar companies coming in and offering solar contracts, turning all that agricultural land into just energy production. So we're kind of trying to use that land. Well, we're doing energy production, keep it for its original purpose as well, and help with the long-term health of that land.
Makes sense.
So if you were going to describe kind of your competitor or competitors, what would you say?
Yeah, pretty much utility solar companies. We basically kind of act as the developer for these solar installations, but we really emphasize working with the rural farm owners to give them the best of both worlds. Right now, there's not a lot of opportunity, and as aging farmers across America get older, farming becomes less practical for them. So rather than selling their land to, say, a solar developer to then develop solar on their land with them kind of not having any involvement in it, they get to still retain their land and their agricultural practice while making a second source of income, which keeps their land, would restore soil quality with, for example, grazing, which is like a low maintenance option as the sheep kind of turn the soil and fertilize it. And then they kind of keep their land as their own and benefit from the solar production after the payback period, that's the most unique aspect of our thing.
Yeah, and I mean, competitors, yeah, it's solar companies, but it's also like any other things that people would be doing with their land. So, it's just like land use in general, whatever that could be going towards would be a competitor. But.
Thank you.
Do we have any other questions? Well, thank you very much.
I would like to ask one more if we have time.
Thanks, Sal. Sure.
So if if the utility solar companies haven't picked up on this, why do you think that is? Is it for them maybe the margins aren't there?
It could be that the margins aren't there. I think it's more likely that they like to have more control over the land and they're not as interested in working alongside the farmer.
Yeah, the value added to the land really wouldn't impact like solar developers, but it will have impacts for these rural landowners that are really concerned about the long-term health of the soil.
And the 50 megawatts is still a smaller scale than a lot of people would be looking at. So it could be scaled up for different size farms and different size projects, but it is still like not at the scale that a lot of developers look at.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you very much. Okay, team 7, we have self-powered autonomous robot for power lines. I see our team members are up. The floor is yours.
Hi everyone, we're Andrew Choi and Jiamin Wang with the self-powered autonomous robot for power lines. So power lines frequently suffer from premature failure, and industry is desperately in need of a cost-effective, sustainable solution to uphold public safety and prevent economic loss. SPAR is designed to fill a gap in existing technology to relieve this pain point, combining vibration control of power lines with inspection and monitoring. Our potential customers are government agencies, grid owners, and hardware manufacturers, and companies have already shown interest in licensing and commercializing SPAR. SPAR will provide greater grid resilience and smart grid integration, which will lead to increased grid reliability, job creation, and protection of national interests. Market assessment and technology identification. The energy sector was given a C- rating from the American Society of Civil Engineers in 2021, partly due to aging infrastructure. Some of the electric grid is over 100 years old, and 70% of transmission lines are over 30 years old. Problems are likely to accelerate due to climate change and additional demand from the move toward electric vehicles and other technologies. However, growing pressures have also led to an increased innovation to modernize the grid. SPAR is our contribution to this modernization initiative, responding to the urgent need to protect and monitor power lines. There are many potential hazards such as wind-induced vibrations, vegetation encroachment, and electrical discharge. These have serious consequences such as outages, forest fires, and expensive repairs. Unfortunately, current solutions have severe limitations. Fixed vibration dampers cannot adapt to shifting wind conditions, manual inspection is dangerous, and current inspection robots are bulky, expensive, and require user input. Furthermore, none of these solutions offer active control and monitoring. SPAR combines and builds upon the capabilities of these subpar solutions. SPAR's lightweight makes it suitable for long-term mounting. Its mobility allows it to adapt to changes in wind conditions and conduct inspection. It is cost-effective at a low price point for its multifunctionality, and it's fully autonomous with no need for user input, offering grid owners and government agencies a single package for vibration control, inspection, and condition monitoring. Economic feasibility analysis. There are over 600,000 miles of power lines that must be protected and inspected. An inspection robot can cost $300,000 for a 3-month lease. Inspection by helicopter typically costs $4,000 a day. An outage to a data center costs almost $9,000 per minute, and the Camp Fire in California cost $16.5 billion in damages. And these are just the economic costs. SPAR will be introduced at a price point of only $500 per unit. The table on the left shows the estimated cost for components at scale, including manufacturing and assembly, for a total production cost of $485. With such slim margins, our business plan is to firstly utilize a low base cost to promote adoption of SPAR and create cash flow and profits through high volume sales. Secondly, we will have high margin upgrades such as additional inspection features. Thirdly, we will offer access to image processing and real-time monitoring dashboards for additional fees. Potential impact. SPAR will lead to tangible benefits beyond those provided to our customers. The development and production of SPAR will create jobs in manufacturing and engineering. Increased grid reliability will alleviate uneven burdens on underserved communities. This includes rural and poor populations that are particularly vulnerable during outages and poor minority communities that suffer from more planned blackouts than other groups. We envision SPAR as a key component of the foundation towards a more reliable energy future. It is necessary to protect both existing assets as well as future investments that will allow us to approach other modernization initiatives with increased confidence. Additionally, SPAR will have smart grid capabilities that will provide critical inspection and monitoring data leading to greater resilience and ultimately greater reliability. Overall business plan. Currently, we are working on a full-scale prototype of SPAR, which is funded by a career award from the National Science Foundation. We expect to begin testing and validation within 6 months and make improvements over the next year. We have access to a wind tunnel, and we will perform field testing with our industry partner, Preformed Line Products, makers of Powerline hardware. We aim to launch a commercial version at scale within 2 years, and we are working with a company on licensing and production. We anticipate large-scale application of SPAR in the US and abroad within 3 years, during which time we will also be working on additional capabilities. We have a team of 4 dedicated to SPAR. I'm a master's student, and Jiamin and Paul are both PhD candidates. We are currently working on prototyping and research. Our advisor, Dr. Barry, serves as PI, and he has over 7 years of experience in industry, along with previous startup experience and access to a network of investors. We also have a provisional patent for SPAR and are seeking funding through the National Science Foundation's American Seed Fund. Thank you.
I have so many questions for you guys.
Sure.
I'll try to condense to one given the time. First is, you talk about there being a sensor in this, right? How's that data getting transferred over from the line to whatever it is that it needs to get transferred to? Is it 5G? Go ahead.
We'll be creating a nodal network. So basically, since there's one robot per span, we're able to transmit data from robot to robot until we're able to actually get it to a collection base where we can take all the data and do some processing and also send it out to the dashboards.
Yeah, I can add a few more information. So eventually it's going to be a local network where hundreds of robots within a certain region, they're going to connect data together. And we will probably also involve a server in a substation, which eventually updates all the data into a bigger server, which through clouds, so that the cloud will be able to analyze all the data and use artificial intelligence to automatically train and analyze, evaluate the wind conditions and the cable's safety conditions, and also improve the operation modes of the robots.
And a follow-up to that, this is a very important one. How is this thing actually going to get deployed? Is it going to be live line work where crews are going to have to install this on a hot wire or an energized cable, or it's basically putting it using safety procedures and you can put it online like you would any other sensor?
Yeah, so this robot is going to be mounted manually, but we are designing the robot structure, the locomotion module, to make it be easy mounted and as safe as possible. And once the robot is mounted on there, we expect the robot to have a very long duty cycle and requires minimal maintenance over a very long period of time, and it will be self-sustainable.
Yeah, I think with transmission lines, that's always a challenge, right? Because it's live, it's energized lines. You can't take them out because there's so many customers on them. So I would like to have a better understanding of what the actual installation costs end up being eventually.
Can I ask, how did you settle on your price point? Can you go back to the slide that compares the different costs for current transmission line analysis? Yeah, and then what's the cost? Can you remind me that you're saying per robot?
$500.
How did you arrive at this price?
So we intentionally chose a very low price point. We wanted to have just a slim margin, and we wanted to keep it as low as possible. So if the cost of production do increase a little bit, we will increase the price to our customer as well. But we want to keep it.
I think just piece of advice: you're better at choosing a higher price point, not increasing the price, but perhaps your margin suffers a bit. But I would think that you could get a much higher rate when compared to the alternatives.
Okay. Thank you.
Also, could be an interesting service model rather than selling these, to provide it as a service. Everything from the dashboard to the monitoring as well. Don't sell the robots, sell the service. I think you make way more money that way.
You mentioned
very good job.
Thank
Very
you.
good job.
So you mentioned you already have conversations going with some partners and potential licensees. Can you just expand a little bit on that?
Yeah, so we did get reached out by a company who was interested in our work. And so right now we are talking with them. They just want to see proof of concept first with the actual prototype. So we will be working with our partner Preform Lime Products. They are based in Ohio. And so we're going to do field testing with them so that we can show this company that our product does work. It is going to be able to reduce the vibrations and do the inspection and do the real-time monitoring. And then so once we're at that stage, they're looking to license the product and actually be able to distribute it in their own country.
So are you seeing that as an augmentation to what you want to do as a business, or are you thinking you're going to have a licensing model in general?
We think we'll probably expand to a licensing model in general. That's something that we're looking for right now. And Dr. Berry is currently recruiting a CTO through his network, or sorry, CFO through his network, so that we can kind of flesh out those kind of details.
Thank you. Great job.
Thank you.
Thank you, team.
Thank you.
Okay. So we'll move on to team 8, molten salt fast reactor bubble detector. Whew, I need to work on my my alliteration a little bit. Great, thank you. The floor is yours.
Good afternoon. We are the Salt Pack, a senior design team at North Carolina State University. We're working with Dr. Alexander Vitaler on a bubble detector for molten salts.
So first, we'll give a brief and to digest, hopefully, overview of a molten salt reactor. A MSR, molten salt reactor, is a reactor in which the fuel and coolant are both in a liquid state in the form of a molten salt. Depending on the company, they'll use a different type of salt. MSR has numerous advantages over current light water reactors, chief among which is its increased efficiency, a closed fuel cycle, and a passive safety features that practically make it walk away safe. The goal of our project is to find a way in which we can quantify the amount of bubbles, which scientifically we'll refer to as voids, present in a molten salt. For those who might not know about voids in a nuclear reactor, they will alter the amount of reactivity in the reactor, which therefore alters the amount of power. So it's an important measurement to quantify. If we can find a way to quantify the presence of voids in an MSR, we can get more accurate readings on the reactivity in the reactor, as well as the circumstances that can cause an increase in voids that are specific to MSRs. So shown below here is our apparatus that we are using for our experiment. A quartz tube is placed within a tube furnace, and a cylindrical cavity is created within the tube with a quartz fritz on the bottom, and a fritz is just recycled glass, quartz glass that is bound together. They have pores in it which allow for bubbles or air to come up and simulate bubbles. And a disc up top, the disc acting as a plunger, which will make acoustic waves. The acoustic waves are caused by a piezoelectric on top of the plunger, and that wave travels through the molten salt and is picked up by a receiving piezoelectric on the bottom of the quartz tube. A gas inlet is then placed at the bottom of the tube to allow air to flow in, which will allow us to simulate bubbles. Next slide, please. The experiment is as follows. A frequency generator performs a frequency sweep from 1 to 100 kilohertz, making the piezoelectric move at each one of those specific frequency points. The waves are picked up by the receiving piezoelectric, and the frequencies are read on a lock-in amplifier. The resonant frequencies of these systems show up as peaks on a frequency chart, and therefore we can see how these peaks change with the presence of bubbles in the cavity. Therefore, we can quantify how the resonant modes of a given cavity change with respect to the amount of bubbles flowing into the system.
Molten salt fast reactors are an advanced generation 4 reactor that is in a race to be developed across the globe. Below are some countries working on these reactors. Our product is unique with currently only simulations able to predict bubbles. With reactor indicators, simulations can predict reactor conditions, but our device would directly measure void density in the core. The bubbles in these reactors impacts the stability of the core. The trend for advanced nuclear has continued to increase over the past few years and is projected to continue to do so. The Department of Energy has also received $2.4 billion exclusively, or from the new infrastructure bill that's exclusive for advanced reactor projects like this. With an ultrasonic amplifier, high performance piezoelectrics, and a frequency generator, a resonance system for a reactor would be expected to cost around $20,000. Our team believes that this could then be sold to these companies for $50,000. Our device's monitoring capabilities can be an additional safety system that could help in the licensing process. Once these reactors are licensed, they will be able to generate safe, clean energy.
So although we are still in our design and prototyping phase of this project, we do believe that a working prototype of our design would be applicable to a real reactor loop in a molten salt reactor and provide a safety measure and detect the void in the salt. With a successful prototype, we could contact major companies researching and constructing molten salt fast reactors and kind of gauge the feasibility and the interest. The actual production would involve enlisting the help of reactor engineers and determining means of production with all the metalworking, et cetera, required.
Open it up to any questions.
Go ahead and ask one. So you mentioned that you want to have a prototype before you have those opportunity or market-based conversations. Can you give me a little more on why that is?
Well, it's the research is constantly changing, and it is a lot of the molten salt reactors are in a heavily design and research based stage at the moment. So even our own prototype is based around how these systems work.
The current field tends to change a lot, and there's only one in the United States, one startup company in the United States that is in their prototype phase with their molten salt. The rest are based in national labs and are more focused on research of molten salt fluid and thermal properties for reactors rather than commercializing the reactor itself.
Thank you.
No problem.
So are those labs and research institutions your kind of first target customers, or are you saying that when they change in the research setting the molten salt that you have to also change the sensor?
Yeah, so right now our research is based off of what these national labs and specific startup companies have published. Obviously, the companies aren't going to want to publish all of their hidden secrets, but the national labs are open with their research. We currently have one company in Denmark, Copenhagen Atomics, that is partnered with us on our senior design project that has been of great help. So we've gotten rather up-to-date information about salt fluid and thermal properties and what we can realistically expect. But, you know, this is all, as we know with nuclear technology, it's ever changing, quite complicated. So we're at the whim of the industry. So we'll have to
who would be the best utilities in the United States to work with on this? Who would be the ideal partners?
The closest to success right now would be Kairos Power. They're headquartered in California, and they're currently making their prototype reactor, molten salt reactor, the Aries reactor, Tennessee, right outside of Oak Ridge. So if we could have a dream target, it would be them. There's Fleeb or Flibe, depending on how you want to pronounce it, in Alabama. They're in the prototypical stage. And then TerraPower in Washington State. They are also on the prototypical stage of design.
I guess my question is, let me phrase it a different way. Who are the largest nuclear providers in the United States?
For our Duke Energy, Dominion Energy, they would be our ideal targets. Our university has worked with them on multiple occasions for nuclear related commercial.
Yeah, if you're looking at, yeah, and assuming that you're interested in taking this to market, I'd also look at Exelon. Or Constellation, they're the largest nuclear operator, as well as Southern Company. Just some good targets for you. Yeah.
That's good advice. Thank you very much. Any last questions?
Well, thank you very much.
Thank you.
Thank you, Team 8. We'll now bring up Team 9. And we have a MiFi DC system, microreactors for EV trucking.
Hi, my name is Amy. My teammates are Kina and Emily, and we're presenting our business plan for MiFi DC. So what's the problem? Currently, the US's supply chain relies on diesel long-haul trucks, and it's failing us. This trucking industry is responsible for about a third of transportation emissions, which disproportionately affect communities of color. Our reliance on diesel will cost millions of lives and trillions of dollars in healthcare costs in the long term. However, an EV semi-truck requires 1,000 kilowatts, and there's a lack of charging infrastructure in rural areas, and it's expensive to upgrade existing utilities as well. The best solution for EV truck charging is MiFi DC. Developed by the Argonne National Laboratory, it is a nuclear microreactor, which means it is transportable, deployable, reliable, and economical.
Microreactor is only the size of 2 home water heaters, but it can charge 15 trucks. It has a thermal energy storage system that can store 13 megawatt hours of electricity to adjust to high and low demand, which makes it ideal for trucks and their strict schedules. The microreactor costs less than $3,000 per unit since it operates at a relatively low temperature and has interchangeable parts that allow for mass production. It's also safe, with low enriched uranium pellets with protective layers of carbon and ceramics. While the predicted levelized investment cost of the MiFi DC system is of 16.5 cents per kilowatt hour of electricity is more than the US residential average of 12 cents, the projected savings are $580 million from switching to electric trucks and $3 billion of fuel savings from idling, lowering overall costs for businesses and consumers. Though there's a high upfront cost for permitting, the MiFi DC system can last 10 years without servicing. In addition, the movement to electrified trucks can save more than $500 per day for businesses and can result in associated health benefits of over $9 billion over the next 20 years. As research advances vehicle design and battery production, the total cost of ownership per mile for electric trucks could be 50% less than diesel trucks, which would lead to rapid investment in EV truck and charging companies.
EVs as a subset of the $732 billion trucking industry will expand at a compound annual growth rate of 60% in the next 5 years due to green industry tailwinds and the rapid growth of the e-commerce industry. 84% of private truck fleets are actively involved in green initiatives like Frito-Lay, which operates the largest EV fleet in the US and has reduced its diesel fuel consumption by 30%. But with increasing interest in electrifying trucks by private companies comes an increasing need for cross-country EV charging stops. Overall, there's a significant unmet market because there's no public company specializing in EV truck charging. The greatest competitor is Tesla with its semi-mega charger and ChargePoint, which has pledged 4,000 fast truck chargers. However, MiFi DC's microreactor features makes it more scalable, deployable, and reliable than its competitors, especially in rural areas. Now we're going to zoom out a little into the overall strategic timeline for success. In 2023, a pilot will indicate proof of concept and be backed by contractors, universities, and national labs. With further utility contracts in deregulated and regulated state markets and investments from governments and private truck stops, MiFi DC will replace approximately 1,450 existing diesel fuel rest stops across the country by 2030. With this renovation and the construction of new stops in rural regions lacking EV charging infrastructure, we can expect to achieve ambitious metrics of impact and increase the resilience of the US supply chain. This is a high-level overview of some of the major partnerships, assets, and resources needed to accomplish this timeline. This business plan will require contracts and collaborations among major players in the trucking and EV charging industries, from private fleet owners to state governments with renewable energy commitments to manufacturing contractors like Westinghouse. MiFi DC will need to secure uranium and heat storage liquids for a factory at scale and capitalize on different market segments to maximize revenue.
Implementing MiFi DC will have positive social, environmental, and economic impacts. MiFi DC will promote equity and inclusion, especially for communities, for members of disadvantaged communities, by getting rid of the particulate matters that disproportionately affect them. For environmental impact, MiFi DC will save 14,000 metric tons of CO2 per year. Electrifying this fleet will also save money from trucks idling and wasting fuel. Cost-effective, safe, and environmentally friendly, MiFi DC can pave the way for a greener truck industry. Simply plug, charge, and go. Thank you. questions.
So this is Sal here. The way I understand your solution is, existing vehicle charging infrastructure. Yes, it's there. There's fast DC chargers too now in the market. Actually, in fact, there are companies that are doing EV charging for trucks as well, ABB, Siemens, amongst others. So is the overall concept here then that you intend to have these like mini nuclear reactors spread out across the country at a very, very convenient cost, but then they're also safe enough that you don't need like expensive security and a whole bunch of other things that come with nuclear technology. Tell me more about how realistic is this idea? Because with EV charging stations, it's electricity, everybody's familiar. Here we're talking about getting into the nuclear domain, which sometimes could be considered riskier.
Yeah, so I think public perception is definitely a big factor in ours, but sort of before it might have been skipped, but the pellets that we're using have actually been developed from over 60 years of research, and they're like much safer than any other researched type of nuclear materials. So I think one of our challenges is in the marketing and in the communication of our concept. The actual cost will be much more effective, like the larger you go and the more you scale. And so our plan and our costs were like 75% of all public rest stops across the United States, and with around $3,000 per unit.
All right, $3,000. And you're still going to need like, a mini sort of a very mini or micro grid to, get the DC flowing from the reactor. So I'm assuming that includes the cost for that as well. Okay.
So in your cost comparison there, you're looking at comparing to regular nuclear reactors. Can you share the economics about the comparison of this to other electric charging stations for vehicles? There we go. Yeah.
So what we did was more like comparing it to diesel. So like the EV savings is actually coming from switching to electric trucks. And so the idea is like switching from purchasing diesel fuel at its cost to switching to electric purchasing. And then the idling savings is like how much fuel you lose when you're idling at these stations.
Did you do any cost comparison to the competitors that are trying to solve the same need?
No, not really.
We're mostly capitalizing on a different market from them. For example, right now, Tesla is developing their super mega charger in Modesto, California, which is directly connected to a comprehensive energy grid, like in a population dense area. However, we think that MiFi DC can capitalize on a need within rural regions where there's less transmission lines and less access to a high demand energy grid.
A lot of the data that I use for this comes from a study that put a bunch of microreactors in rural Alaska and had really good success with that.
Thank you.
There was one additional, sounds like it's been answered. There was one question in the chat, but I think we've gotten to it. Are there any last questions?
It's an interesting concept. I would just echo Molly's comment about, some cost comparison between existing technologies that are able to achieve that, just alternates that are out there in the market, and perhaps even talking about the LCOE or the levelized cost of energy comparisons when you're making those sort of analysis.
There was another question comment as well that was, do you feel that there are added nuclear proliferation risks by adding small reactors all over? So certainly things to think about going forward. Okay, thank you. Last but absolutely not least, we are moving on to Team 10 and our final pitch team for the day. It is Appalachian Biochar. I do want to note while our last team is coming up that just after the last pitch, we will be moving into judges' deliberation and have our featured guest speaker, Jason Massey, who has some great stories for all of the range of attendees. He is truly the perfect guest speaker for us. So please, I'm looking forward to that very much. And we will get to that in just 10 minutes. Thank you. The floor is yours.
All right, hey everybody. I'm Alex Gray, and this is Appalachian Biochar. The loss of topsoil is a threat to agricultural production, ecosystem function, and soil-based carbon sinks. Reducing our carbon emissions is not enough to solve the ecological problems we're facing. Carbon must be drawn down from the atmosphere and sequestered. To add to the damage done by agriculture, forestry, and exploitative industry, rural America is suffering from poverty and lack of opportunity. Appalachia is a microcosm of these effects. Using waste wood, biochar provides a mean of regenerating soil, increasing food production, and sequestering carbon. It can be made at varying scales through various production systems geared towards different needs and resources. Our goal is to make biochar a widespread phenomenon. Using existing infrastructure, we aim to build a network of biochar producers and users to connect people, empower people, heal the soil, and heal the planet. In Appalachia alone, 15 billion kilograms of carbon could be sequestered. We're proposing a two-part business plan involving biochar production as well as biochar consultation and education. On the production side, we intend to produce biochar for farmers, gardeners, and foresters. Production will take place in situ, in land clearings and places of slash burning, as well as in a centralized location where feedstock materials will be brought and turned into biochar. We can produce a variety of biochars using different feedstocks, production techniques, and post-production preparation. The other side of the business revolves around consultation and education. We'll provide local producers with the necessary skills, information, and biochar production technology, as well as the software to chart biochar use and to suggest biochar types and application rates based on soil tests. We'll also offer community biochar workshops. Additionally, we'll build an online marketplace to connect biochar producers and users. This will enable a decentralized biochar market to grow, empowering producers and offering a wide variety of biochar-based soil amendments. We will empower local producers to make quality biochar, get it tested, and then offer it to their local communities and make a profit. This business would be a worker-owned cooperative. On the production end, we anticipate finding customers through the existing infrastructure of cooperative extensions. This map displays all the counties in North Carolina, each of which has its own cooperative extension. These offices have deep understandings of and relationships with the farmers in their communities. We will also build a network of biochar producers and users, enabling a larger industry to take shape. After receiving the initial support to begin producing quality biochar, local sellers can leverage our online marketplace where they can offer their products to their local communities. Through decentralization, a wider variety of biochar products can be offered while investing in local farms and businesses. As our business grows, more production hubs as well as independent producers can join in. With a startup cost of around $63,000, we could begin producing around 25 tons of biochar a month, which would quickly scale. This would initially support 5 full-time employees at $20 an hour. Initially, 80% of the revenue is from production, 10 from consultation, 9 from carbon credits, and 1 from commissions on the online marketplace. A ton of biochar costs around $300 to produce and sells for around $750. In Appalachia alone, using only 10% of the wood waste stream, an annual profit of $60 million and an annual production of 300,000 tons of biochar could be realized. The impacts of such a business are far-reaching. Agricultural yield can be increased, new economic opportunity can be created for farmers and rural Americans. In Appalachia alone, if a quarter of the farms applied biochar to a quarter of their land at a rate of about 10 tons per acre, 15 billion kilograms of carbon could be sequestered, which equates to around 30 billion kilograms of CO2 equivalent sequestered. Future expansion opportunities exist in forestry, ecosystem restoration, and more. This model is also pretty scalable and could easily fit the resources and needs of other regions. Where else can you sequester carbon and increase food production using a free waste material? Imagine the possibilities. Thank you.
I have a first question for you, Alex. What are the alternatives there? Is there nobody else doing this in the market today?
Alternatives as far as a soil amendment or
the biochar?
Yeah, so I mean, locally they're like in Appalachia, or Southern Appalachia at least, like there's nobody really selling biochar, but I know in Atlanta there's one, in sort of like Ohio somewhere out there, like there's a lot of companies, especially as you go further out west, that are making and selling biochar. I think, the utility of this idea is making a lot more biochar and getting it out and empowering smaller, like less large producers, like small farms and people like that, to produce their own and create kind of more unique tailored biochar products and stuff like that.
So in your economic analysis, did you had some clarity in terms of the profits you'd be making based on some pricing estimates? And yeah, there we go. So sells for the next one. Yep.
Sorry.
It sells for $750. So where did those numbers come from in terms of like the need that the farmers are, seeing and willing to pay?
So as far as these numbers, I basically just kind of surveyed a bunch of different biochar businesses and looked at their price points, which vary like a lot based on, like a ton generally sells for $350, but I put $750 here because, like, looking at our initial, kind of starting up, like we wouldn't be selling only tons, we'd be selling like 2 gallons and yards and like smaller quantities like that, which are worth a lot more per unit of biochar. So that's where I got that from. Does that answer your question?
Yeah, thank you.
The one question I have is, how much have you looked at monetizing the carbon sequestration credit through various trading schemes, and what organizations would you think you need to engage with to monetize those?
Yeah, I've been looking into that. So there's basically 2 different routes I've thought of, and I think I briefly mentioned it in the slide, but not much, because I have been working on trying to like talk to one of these companies. And so I've read some of their like online literature and stuff. And basically it would definitely be doable to incorporate that. There's not a whole lot of money in that. Like most of the money comes from like, actually selling the biochar. But it would certainly like, help a business like this. And then it would slightly, empower the local producers and people like that. And this would be a kind of a neat chance to like give the power of a large organization to a bunch of small local producers and, allow them to, capitalize on that. And then the other side would be like I know that my school, Appalachian State, like buys carbon credits. So like finding like local institutions that are interested in like carbon offsets and selling directly to them rather than going through an organization.
Thank you very much. Are there any last questions? Oh, our timing is great. So it is now time to transition. If you could please stop sharing slides, we will get everyone in one place. Thank you. Okay, so at this time, we want to thank and congratulate all 10 of our teams, give them a virtual round of applause. We know you put a lot of hard work into that, and we are excited to see the judges' decisions. Between now and then, we have a few different things that we would like you to do. First of all, you have the great fortune and pleasure to hear from Jason Massey, co-founder and CEO of Industrial. He is, in fact, the perfect speaker for us today, and for all of us, whether you are a student team member or someone who is part of the industry, a company, a part of a nonprofit. Our attendees are quite varied. He has really written his own story of innovation, commercialization, and energy tech business growth. He also happens to be our latest and greatest winner of the RTCC Clean Tech Innovation Award for Clean Tech Impact Energy. So Jason, I am actually going to turn over the emceeing of this part of the event to my colleague Emmett Owens. He will be your point person here. I'm going to be going with the judges, and we will be coming back after the guest speaker and a few quick activities, including a student member survey and audience choice awards at the end of that time period. And we will see you back when the deliberations are over. Thank you so much.
Thank you, Deb. And as Deb mentioned, Jason will be providing us with some inspirational words. And so, Jason, if you want to take the floor here, and I've got your video that you'd like, whenever you'd like me to play that, I can tee that up too. So, thank you, Jason.
Yeah, absolutely. So, can everybody hear me?
Yes.
Okay, cool. So I think the reason Deb thinks I'm good for this speaking series is kind of looking back, some of the best working relationships and successes that I've had have come through actually university business plan competitions. And as I kind of go through my narrative here, hopefully those dots will get connected. But it is a little surreal talking about my experience. I still consider myself of college age, and then I look in this Zoom camera and I see all the gray on my beard and stuff, and I'm like, yeah, I've aged a little bit. I actually started out doing electrical work in high school and college, so wiring commercial buildings, and I say that out of the gate, and it's more relevant later. But I started out at NC State studying physics, did that for 2 years. That physics math was a little too complex for me, so I decided to transition into finance, simpler math. I then left North Carolina to move up to New York City and became a stockbroker back when they were actually still called stockbrokers and not financial advisors. And that really was the start of my MBA, my unofficial MBA. It really helped me assess business models, understand financials. It helped me appreciate kind of short-term and long-term risk-reward curves that actually governs quite a bit of my thinking today. It helped me learn not to be scared to actually sell and pitch myself or ideas, and help tell stories that actually compels people. And it helped me not to be scared to actually talk to what I would consider like larger than life people. And again, that'll be relevant later in this kind of story. I did that for a bit, a lot of cold calling, a lot of pitching, Compact Computer and Dell stock. I generally don't like conflict, but it kind of worked up at the end of my first year. My managing director really liked to, what we would call churn accounts and make a lot of commissions. And I got angry with him and told him that I'd make more money than him by the time I was 30. And I thought for sure I was going to get fired the next day. And the next day he came to me and said, hey, we're opening the office in Jackson Hole, Wyoming. I really want you to come out there and help me launch that. And so I was like, I don't know if I even like this guy. Am I going to move out to Jackson and open an office with him? But I did, and he happened to be the brother-in-law of the chairman of the firm, and I got really close to the chairman of the firm. And I think that was a function of being authentic. Maybe he felt sorry for me with my Southern accent, but nonetheless, I struck up a relationship with him. And that was about the time that the original internet bubble was heating up. So a lot of you on this won't remember the original internet bubble or even some of the companies that were involved with that. But that pulled me back into New York City. I got to help launch the new venture capital funds at the firm. We raised a little over $200 million and deployed that across close to 50 startups, mostly in Silicon Valley. At that time, I had read a book by somebody what I would consider a mentor, a guy by the name of Randy Commissar. He wrote a book called The Monk and the Riddle. And before I went back to New York, I was evaluating, there was a lot of like university-based venture capital funds funding startup ideas. A lot of the ideas that I heard coming onto this call, and I was going to start a NC State venture capital fund, and I reached out to Randy, the author of the book, and I asked him about the idea, and he was pretty blunt. He was like, anyone without a real clue can make money in a bubble like we were in the internet bubble. He's like, but real businessmen and women know how to make money in up and down markets. He was like, go get some experience. So actually, that's when I decided to go back to New York, really get into the venture capital side of the business versus trying to start my own venture capital fund. That took me out to Silicon Valley, moved out there. My wife and I were out there for almost 10 years. I had no business being in venture capital at the age of 24. I thought I knew what I was doing, but in retrospect, I really had no idea what I was doing. But it got me to meet some really thoughtful people. The market tanked. I got some really good life lessons in capital allocation. Lots of companies that went out of business, lots of companies that needed new capital. Again, sort of my joke that was in my part of my MBA was going through that experience. But what I found was that I loved venture capital and startups and investing and helping them kind of grow and nurture, that I loved it so much that if I wanted to be good at it, I needed to leave it, do what Randy said, go get some real life experience, and then come back, if I want to be good at it. Go out, sweat payroll, hire people. Fortunately, have to fire people sometimes. Really understand what it took to build a business, and it's like almost 20 years ago when I left venture capital and started working with startups. So I did a lot of work on handshakes. So there weren't big contracts that got signed. Previous investors that I worked with, they had a startup, they needed some help on business development. I'd literally, without negotiating a salary, would work on a handshake. I didn't make a whole lot of money, but fortunately, I didn't need a whole lot of money at that time. And so I did a lot of work, again, on handshakes, pay it forward. That ultimately paid off for me when a group that I'd worked with on some wireless deals landed at a publicly traded company called Covad Communications. So not COVID, but Covad Communications, one of the first big DSL broadband providers. And they asked me to join the company. I got a nice big salary working at a public company. So all that free work I had done in the past, it started to pay off. And I ran strategic development then, looked at new wireless tech, we were doing the free Wi-Fi hotspots in Silicon Valley. And this kind of brings me full circle to not being scared to talk to larger than life people. We were trying to bundle broadband services with wireless phone service, IPTV, so early versions of streaming, and Virgin had just launched Virgin Mobile. Richard Branson, with his marketing genius, would call it foreplay, and we just could not get through on traditional business development channels, traditional sales. And so I decided to write a handwritten note to Richard Branson, and my handwriting is awful. And after 16 tries and finally getting it down, I sent it off. In 2 weeks, I got a response, and I got his private email, and he started interacting with me and introduced me to the right people so that we could strike a deal with Virgin Mobile and Covad. So it was really important, that early experience that taught me that if I had something of value, or I thought was of value, to articulate to somebody or get their feedback, that even though they may be, a billionaire in the UK, I had every right to reach out to them and tell the story and have an ask. I ultimately talked my way into getting laid off with a good severance package. Our company went private. They really weren't going to do much new strategic stuff. So I took that severance and I didn't tell my wife, and I rolled that into my first angel investment. So kind of the early stage. So what a lot of you guys would go after, funding your senior design project, you may go get some angel funding to see if it can actually work. That was in a company called Tapulous, which made the #1 iPhone game on the App Store. This is when the App Store first launched. It was called Tap Tap Revenge. That company should have failed multiple times, but ultimately we were able to sell it to Disney, and I made some good money off of that. There was a time that we decided to move back to North Carolina, kind of start a family. I said I would never, ever move back to North Carolina from California, but we did. And that money that I made off of that angel investment allowed me, and this was one of the early, me working with a spin out of the university. So I'd worked on a spin out of a micro turbine, so a 10-watt turbine that spun up on an organic Rankine cycle methodology and using ethanol. And that was a DARPA funded project out of MIT and Duke. I worked to spin that out, got involved with a lot of crazy tech transfer with the university, negotiating that. Had no salary, was making no money as the CEO and president of the company, but probably some of the most fun that I ever had. We would have board meetings at 2 a.m. We'd be running experiments in downtown Durham in the old laundry building, trying to spin up this turbine and get the prototypes working. And it was just a lot of fun, but it was way, way, way too early for the market. And ultimately we had to wind it down, and it was ultimately a failure, but I met lots of people that I would get in the trenches again and do a startup. So that after that kind of wound down, I started what's now Industrial IO. So the original name of the company was Sustainable Industrial Solutions, a real sexy name. And our mission was to accelerate the industrial transition to low carbon economy. And that was actually a direct result of the work that I had done with Al Gore to launch the climate project in Beijing, and then working with Richard Branson on what was called the Carbon War Room, and was now part of RMI. And seeing, especially in China, the amount of work that was going to have to happen to make a dent in low carbon manufacturing, it scared the hell out of me, quite frankly. And that it was the impetus to start this company. I said at the beginning, I did electrical work in high school. I said I would never, ever do electrical work again. And I started this company, and I found myself in electrical panels, putting in CT clamps on phase lines. So all that previous experience had actually served me well. So that, I kind of take a step back, that micro turbine was a direct reflection of a PhD student's business plan competition at Duke. And that's how I got involved with it. And then fast forward with industrial, I started working with who is now our CTO. He was a junior at NC State working on a startup. And I think, Emmett, you got the video. We can watch that really quick. And I'll put
it up right now.
It was fascinating to see how consistent our business has been. And this was back in 2012 when John was a junior at State. And this was a business plan competition presentation that they did.
Hey, I'm John.
I'm Chet.
I'm Kevin.
And I'm Dryer, and we're Green Energy Management Systems, or GEMS. Managing energy consumption is a challenge, both nationally and globally. According to the Department of Energy, U.S. industry consumes more than 31 quadrillion BTUs annually. That's 1/3 of all energy used in the entire country. A Lawrence Livermore National Lab study found that inefficiencies in the industrial and manufacturing sectors waste 20% of the energy they consume. In his State of the Union address, President Obama issued a challenge.
Of course, the easiest way to save money is to waste less energy. So here's a proposal. Help manufacturers eliminate energy waste in their factories and give businesses incentives to upgrade their buildings. Their energy bills will be $100 billion lower over the next decade. And America will have less pollution, more manufacturing, more jobs for construction workers who need them.
As everyone looks to do more with less, companies are turning to technology and efficiency to help them deliver their products and services while maintaining tight budgets. With companies incentivized more than ever to add intelligence and reduce waste, the appetite for data-driven solutions has never been higher. To fight and reduce waste, you have to know where all that energy is going. Right now, most manufacturing plants don't have any more information than you might find in your home's power bill. One paper bill at the end of the month. Granular monitoring of power throughout a facility can provide not only real-time insight for operators, but can also drive more intelligent decisions, improving efficiencies and updating equipment. Using wireless sensors and easy-to-understand visualizations, our solution enables facility managers to see and understand when, where, and how they're using power. By providing real-time metering of individual devices, our solution shows customers an energy profile of their entire operation, detailing inefficiencies and suggesting ways to correct them. From improving power quality to identifying cheaper times of the day to run operations, GEMS helps companies more intelligently control their operations and optimize their power costs. Within the next 9 months, our product will be ready for initial deployment. North Carolina is home to more companies developing the smart grid than any other area in the country, making it an ideal location to launch our technology in an industrial setting. North Carolina provides GEMS with an ideal entry market, home to over 800 mid-tier manufacturing facilities with an average annual revenue of $66 million. In addition to approaching manufacturers directly, GEMS will work with energy sustainability consultants to identify ways to green industry and save businesses money. These sustainability consultants act as our evangelists, promoting our technology to their industrial clients to help them green and improve control over their operations. By focusing on industry, we gain the ability to both launch our operation in a way we can respond to our customers' needs and refine our product based on their feedback. In the first year, we will have 2 of these facilities where we will rely on sales, data hosting fees, advertising revenue for promoting partner products, angel investing, and grant funding. In years 2 and 3, the refined product will be available in larger quantities, and we will expand to 6 to 12 facilities. With the expansion comes additional revenue streams from sales, partnerships with utilities, and charging for third-party access to the valuable power data provided to us through our operations. We are a group of computer and electrical engineering students at NC State. We saw a real gap in the energy management sector. Companies are throwing away energy right and left, and the worst part is, most of them don't even know they're doing it. We think that with our unique skill sets, backgrounds, and educations, we can fix this global issue. GEMS. Smarter decisions for smarter energy.
I'm so proud every time I watch that video. We showed it at all hands in our company on our anniversary the other day. And so John Crawford, the guy that introduced himself at the beginning, he is now our CTO of the company. They made that video in a weekend. They won that business plan competition. It was during the American Recovery Act funding. It was part of DOE's investment in a lot of the local community colleges. So now John, fast forward to today, is our CTO. He's developed a system that literally we can turn large cold storage facilities, these facilities that are 500,000 square feet, They store all the bacon, pork chops, chicken, strawberries, squid. 30% of the US food supply goes to these facilities that are our customers. And the technology that John has developed since that video he was on can turn a cold storage facility into a 3 megawatt to 4 megawatt thermal battery. And fast forward to today, it was really hard fundraising for our business. We're historically not in a sexy space, although that's changed over even the last year. We didn't pattern match really well with traditional venture capital funding, even though I was a former venture capitalist. So we weren't a pure software play, and we did some custom work, but we were persistent and really bootstrapped the business, and were diligent in finding the right partners. And again, fast forward, that same guy you see in that video as a junior at NC State is going toe-to-toe talking to the CTO of the largest utilities, largest energy suppliers. Back in April, we raised a round of funding through Engie, which is one of the largest utilities on the planet based in Paris. And now we're, again, talking to some of the largest oil and gas companies on the planet. And again, I can't even, I feel like I'm understating the trajectory that somebody like John had gone through from being a student on a senior design project, participating in business plan competitions, and where that ultimately has brought him. He'd probably give you a different story and how I talked him into joining the company. It's probably the wrong decision for him, but I'll let him tell that story one day. But I guess I would sum up some lessons, and I'm happy to jump into some Q&A. Is, first of all, never say never. Try to live a relatively modest lifestyle, especially at this stage, because it will give you financial optionality to take risk, and risk is really important when you're trying to be innovative and do new things. So remember that risk reward curve that I talked about at the beginning. And that risk reward curve, it will transcend money as well. And it really applies to experience that will pay off later for you. I'd say invest your precious time giving back to these university programs, mentor, have a coffee with somebody that's coming up, nurture that talent. It may not always pay off, but when it does, it's pretty magical. I'd learned in Silicon Valley that paying it forward is the best investment and best return that you can get. So even if you're just coming out of college and just coming out of university, you still have experiences that you can provide to people coming up. I'd say have fun. Starting and building a company is really hard. It's not as glamorous as it sounds. At times you'll doubt yourself, but you've got to grind and push through it. So if you can find joy in the journey and have a fire in your belly to solve a problem, then that grit and perseverance that you need to survive to the next day will be a lot easier. And you can have fun doing hard things with a team that you like. Humans are kind of a mixed bag of experiences. We can be very empathetic. We can be passive aggressive. We can be hypocrites sometimes, but we're constantly evolving. And I think one of the most important attributes that you can have is being authentic. And when you're authentic with all the warts and challenges that come with that vulnerability, it really attracts people to you. They want to work with you. They want to get behind what you're doing. John Doerr, a really famous venture capitalist at Kleiner Perkins, will say he'd rather have an A team and a B technology than a B team and A technology. And he'll often say he wants to find a team that he can get in trouble with, meaning there's going to be times where it gets hard, it gets difficult, but if you can find a team that you really want to be in the trenches with, it makes it all worthwhile. And I can, again, point right back to John Crawford and our CTO. I would die on the hill for him and would do any type of startup with him. And that was, catalyzed through a lot of hard work that we've done with this company. And it all started with these business plan competitions at the university. So I'm gonna stop rambling and open it up to questions, and hopefully I'll be helpful.
Well, Jason, let me thank you so much for sharing your great insights and for sharing more about your experience. I know our pitch teams really appreciate it, and our audience really appreciate it. And I personally have known you probably very on the periphery for about 6 years, and I didn't know you had such an extensive background from DARPA to tech transfer to angel and VC investing, and that's a heck of a lot of experience. And so, I've been impressed by industrial and your growth over the years. It's a really been impressive.
And I don't look a day over 70 now.
I mean, I don't know how you do it. I mean, all that risk you took. I mean, how did you go home and tell your wife you took a separation agreement? A severance package.
She didn't know until we sold the business to Disney, and then she was really excited and happy.
Okay, that's how you got away with that one. Good to know. I was curious, like my wife would shoot me. Well, she would shoot me. She'd be upset.
It was a risk reward curve. And I could have very easily fallen on my face and got in trouble. So
you could have, but I'm glad it worked out for you. So are there any questions from any of the panelists? If you're a panelist, it's one of the student team pitches, feel free to turn your camera on and ask a question, or if you're the audience, feel free to use the Q&A. And so, you've had some really good advice, Jason. And so, you learn from failure. And so what do you think that was an important part of your evolution, was learning from the wind turbine failure?
Yeah. Oh yeah. Like I mean, it's become a little bit of a cliche to say, fail fast, learn from failures. Failure still hurts. It's not fun. But you do learn so much more from failing than successes. Successes can actually give you a little bit of a false positive. And failures are really where you dig deep for the pay dirt and how you evolve and get better. And I probably fail 2 or 3 times a day, still make wrong decisions and put my foot in my mouth many a time.
Awesome. Any questions from anyone else? Thoughts you'd like to share? Y'all are a sharp group.
The pitches that I saw were really impressive. They like super high tech.
Yeah, it certainly was impressive. I was, I know this is my mindset, and I imagine you're this way too, Jason. Just enough to know how to connect the dots and the pieces of the technology together, but how to actually make it work, probably not. So I understand that completely. And so I want to be respectful of your time here, and thank you for sharing your wisdom. Unless there's any questions here, I'll give you back part of your day, unless you want to hang around to see who.
I'll hang out for a bit. Yeah.
Awesome. Thank you, Jason. I appreciate it. And I'm gonna.
Thanks, Emmett.
Folks, if you'll give me 1 second here, I'm gonna transition over to a few key announcements that we have as we wait for the winners. And so let me get my share up. And so first ask is for our student teams. And so what we'd really like you to do, if you haven't already done it, I know there was some chat going on back and forth in the panelist chat box. This survey is only for the student teams. If you're a student competing today on a pitch team, feel free to use this QR code or this link. It's really helpful for DOE and future endeavors to have your feedback, to know, get your honest feedback. And so I'll move on to our next. And so the next part of this is our Audience Choice Award. And so audience members, we have a question for you. If you have attended the event for at least half of the pitches today, so now, do your own truthing. You are welcome to vote for our Audience Choice Award. So select the team that you think exemplified the experience, best exemplified the spirit of the competition, and which team had the best business plan to commercialize energy. And then the most votes, the team with the most votes will be awarded $200 in gift cards to be divided amongst the group members. So there's skin in this game. So I'll get the poll posted right now. We can see here. Audience choice launch. So I'll give us about 60 seconds to 90 seconds to get your feedback about this from the audience. And so. So good news is we've got about 5 minutes before we announce the winners, and so we're going to dive into some energy trivia, and I'm going to end this poll. So if you haven't voted, I'm going to give you a few more seconds. If you haven't voted, you got a few more seconds. And 5, 4, 3, 2, ending the poll. We'll announce the winner of the audience awards in just a second. If you give me 1 second, I'm going to message over the winner. Message over to Deb so she knows the winner of the audience award. So I'm going to put up another poll here. We'll go into one of the first questions, try to keep things lively. And I'm going to open this up to panelists as well, so we can have some fun here. So the first question is, in 2021, which renewable energy technology had the most patents filed in the United States? And so you've got a few choices there. Take your guess. So let's give you the answer for this. So for this poll, and let's see what our numbers look like. Sorry, we're getting some of the logistics handled on the back end of this, and I will have the winner. So for the which had the most patents, it was batteries. It had 508,000 total patents, and fuel cell had the second most with just under 200,000. And so it explains why I think 4 pitches were related to batteries today. So an interesting poll. We'll go over here and it looks like our audience had batteries as well. So we'll end that poll. Well, the second question for everybody to engage with. This is one of my favorite ones, I'll be honest. What percent of energy used for electricity generation is lost in conversion? So this is a really fun fact. It blew my mind when I first learned this in my infancy 8 years ago in the energy space. I'm going to leave this open for 10 more seconds if you want to take a guess. No Googling this answer either. I'm sure all this is very easy data to Google. But so what percent? The answer is actually 60% of energy is lost. 60% of energy used for electricity generation is lost in conversion. So if you're thinking about the AC to DC conversions and all that good stuff and all the other kinds of things going on in conversions, it's really, really interesting to think about that from that perspective. And so I'm going to go to a different question, question 5. True or false, in 2021, renewable energy sources accounted for about 12.6% of the total U.S. energy consumption and about 19.8% of electricity generation. Get your answers in, get your answers in. So the answer for this is true. Looks like a lot of you got that right. I'm going to do one more question as I transition to different slides. This might be a really, this is my favorite question. So true or false, clean tech could be worth more than oil by 2030. Is that true or false? I'm going to get the slides up here for Deb for you. So that is a true answer. So about clean tech will be worth more than oil by 2030. So who knew? I wouldn't have guessed it, but that's how we're headed. And so it's really exciting time to be in clean tech. It's really, given that context, really important, some of the work and thought leadership that the student teams have taken on. And so Deb, are you back in the building?
I am back.
Awesome. So we've got some great news to share. I'm going to put this slideshow up. I'm going to share my screen and we will be good to go.
Okay. As we're doing that, we are ready to announce, but before I do, I'm going to turn it over to Damien to share some words from the judges. Maybe. I saw him raising his hand. Can we find him? Oh. Damien, do we have you? Oh, no audio. Okay. Let's see. Can we give Damien audio a minute? Let's see.
Yep, I just fixed it.
Perfect. Does that work, Damien?
Okay, here I am. Thank you, whoever took control. Can you hear me okay?
Yes.
Wonderful. So this is my first pitch competition virtually, and I will say that doing a pitch competition and a presentation like this virtually is probably more challenging than even doing it in person. And so for all those teams that managed through this process, I think you all did a phenomenal job. It's clear that a tremendous amount of work and research went into preparing everything that all the teams did today. And it was wonderful for me to be involved on the judging side of these competitions, given how many I participated in through my graduate career. So wonderful job, everybody. And Deb, over to you.
Thank you so much, Damien. And thank you again to the judges, to Jason as our guest speaker, to the team putting on the event, and to our supporters at the Office of Technology Transitions and NREL. This has been our first pitch competition and certainly our first virtual pitch, and it has been a really, really inspiring experience. So with no further ado, we are going to start with our overall runner-up for the competition. And I don't have power, so I need Emmett to forward it. Congratulations to our regional runner-up, Solar Shepherds. There was a great deal of enthusiasm for your team and your project and your business plan. Thank you. Okay, our next winner is our overall regional winner, self-powered autonomous robot for power lines. Congratulations. You are the winners of the $2,500 regional prize, and you will be proceeding to the national competition. One thing I wanted to note is that the Office of Technology Transitions, as well as RTCC locally, will be coordinating any additional mentoring for any of the teams that do move on to the national competition. And we are so excited to support you and to see you move forward. This is wonderful. Okay, now we are very excited to name 4 additional regional semifinalists. And just to re-explain what happened there, we had the opportunity to name regional bonus category semifinalists. These will be evaluated with all of the other regional semifinalists. A finalist will be then selected for each of the categories, awarded $2,000, also provided mentorship between now and the national competition, where they too will be able to present. So we're very excited about that. So moving on to our bonus categories, congratulations to GeoExplore. We're excited to put you forward for a GTO semifinalist review. Appalachian Biochar, we're very excited to put you forward to FECM. You're doing a lot of very innovative things. This has been so exciting. Nuclear energy, we are going with MiFi DC system. I believe we have one more for solar. Yes, for CETO. Solar Shepherds, once again, our overall runner-up and a semifinalist in the solar category. So thank you and congratulations. I had the great pleasure of getting to listen in to the judges deliberate, and there was amazing, amazing feedback about what you all are doing to think creatively and move your business plans forward. And now you have about a month to continue that work. So semifinalists, you will hear in the next week or so about whether or not you have been selected as finalists. We'll be putting you forward this evening, and then we will match you with mentors as well. So our final category, audience members, you were able to choose this one, and you also chose Solar Shepherds. So congratulations. Your team will be winning $200 worth of gift certificates for Grubhub, and you can, we will reach out to you to make sure we get those to the right folks, and we congratulate you once again. I wanted to wrap up this exciting evening, just saying congratulations and thank you. I think I've got one more slide just saying that, but thank you To all of our teams who did the research, did an excellent job preparing your pitches and put yourselves out there. Thank you also to our esteemed judges. We couldn't have asked for a better judging team, and we are so grateful for the success that you allowed us to have as an event and for our students. Thank you to Jason Massey, our featured guest speaker. Thank you to Emmett and Megan, our team behind the scenes. Thank you to our board members who were able to spread the word and get many of our attendees here. And thank you to all of our participants and attendees for being part of this event. We do hope to do more of these types of events in the future, and we encourage you to reach out to us for any opportunities where we can support your work and we can work together to really go for that transformation through collaboration in this clean tech industry. So thank you so much and good night.